Hey, how's it going? I'm your host, Gerhard, and you're listening to Ship It, a podcast about getting your best ideas into the world and seeing what happens. We talk about code, ops, infrastructure, and the people that make it happen. Yes, we focus on the people because everything else is an implementation detail. I'm fairly certain that you have heard of Cloud Native. Maybe you're already developing and running your applications in a cloud native way using Kubernetes, GitOps, and the new kind of observability as promoted by OpenTelemetry. But what is cloud native? What are the fundamentals that you should know about? What are the guiding principles that you should keep in mind as you're choosing a project from the cloud native landscape? Yes, the trick is knowing how to combine these projects, as well as figuring out what makes sense when. To answer these questions, I'm joined by Katie Gamanji, Ecosystem Advocate at CNCF, former Cloud Engineer for American Express, Condé Nast and Microsoft. Katie is teaching the Cloud Native Fundamentals online course, which is a practical, hands-on approach that is accessible to everyone, everywhere. Even if you're doing Cloud Native today, what can you learn from Katie's perspective? From our brief discussion, I have learned why separating CI from CD is a good idea, what would non-Kubernetes cloud native alternatives look like, and what is important when it comes to understanding how applications behave in production. The best part is at the end of the interview. Big thanks to our partners Fastly, LaunchDarkly and Linode. Our bandwidth is provided by Fastly. Learn more at fastly.com. Feature flags powered by launchdarkly.com. And we love Linode. They keep it fast and simple. Check them out at linode.com/changelog.
This episode of Ship It is brought to you by Render, the zero DevOps cloud that empowers you to ship faster than your competitors. Here's Anurag Goel, CEO of Render, sharing why developers choose Render over Heroku and how they're innovating much faster.
A lot of Render customers come to us from Heroku, and they tell us Render is what Heroku could have been. I think it's because we offer a more streamlined approach to hosting modern cloud applications at a significantly better price point. Applications on Render heal themselves and scale automatically, giving developers the features and flexibility of something like Kubernetes, but without any of the complexity. We're always working to bring the latest industry advances to our platform, so your applications can leverage the state-of-the-art in the cloud without you having to do or learn anything.
All right, learn more about how Render compares to Heroku at render.com/compare or email changelog@render.com for a personal intro and to ask questions about the Render platform. Again, that's render.com/compare or email changelog@render.com.
We are going to ship in 3, 2, 1.
I like to start with a story. And the story is like how we met, because I thought that was like a very interesting way. Do you remember how we met?
So the way I actually met was during the End User Partner Summit, which I was leading at the time. And this was an event only for CNCF end users, pretty much everyone who uses cloud native, but they don't sell it. And as part of that, we had a networking session or like a breakout room where we were just able to maybe interact a bit more with other people. So kind of still getting that networking vibe in a virtual space.
Mm-hmm. Yeah, so what I remember is that during Priyanka's happy hour, that was like a session that we did at KubeCon, the European one.
That's right. Yes.
That was it. We had breakout rooms, you're right. So people like randomly, 3 or 4 people be randomly picked and they would like have a breakout room and then they would chat. So in one of those sessions, we ended up in the same room and there was like 2 more people, I think.
Yes.
And we were talking, I know Splunk was mentioned, I believe. Is that right? Splunk, Redis Labs, something like that in that conversation.
There were many things mentioned, yeah.
Was Snyk mentioned as well? So just a couple of technologies were mentioned and what people use and, you know, how's it going? Just like a general one. And then a few weeks later, after KubeCon, I found out about this course, the Cloud Native Fundamentals that you've just launched. And in that tweet, which by the way will be in the show notes, we said that you wrote that after 4 months of very early mornings and very late nights and a lot of hard work, it's finally done and you're very happy for it. And I was thinking, finally, a cloud native course that people can take is a practical one that takes a while and takes people from nothing all the way to understanding not just the landscape, but how to use specific tools. It's a very practical approach, which was sorely needed. Because the cloud native landscape, let's be honest, it's so confusing, even to those that know it. There's like so many things there. And it's not a bad thing because it's meant to be big. But how do you start? What is like the first step that you take? I think that is less my perspective. Maybe you disagree. Do you disagree? It's less confusing to you, or?
Well, let's put it this way. I do remember my journey when I started to use cloud native tools. And this was around when Kubernetes was around for 2 or 3 years. It was still very brand new. I do remember actually I had to set it up the hard way before it was called the hard way. When I had to actually write the systemd file units and files and actually write all of the configuration there to actually make sure that the kubelet is going to be up and running on the machine. And at the time, I managed to have a 2-node cluster, but it took me a lot of Stack Overflow, a lot of reading for the docs, a lot of back and forth. It was not very, very concise. And now we have the community has been working quite heavily on improving the documentation. It's out there. It's pollinated. It's in very good condition. It's maintained as well, up to date. But now the problem is that everything is overwhelming, because when you talk about cloud native, it's not just Kubernetes. You have so many other tools around it. So what I'm actually trying to outline with this course is more of cloud native is a practice. The tools can vary from one organization to the other. But once you understand the fundamentals, once you understand what it actually brings to the table, then you actually be able to choose the right tool for your use case. Then you'll be able to explore further and maybe even advance some of the technologies further. So one of the things I wanted to kind of provide here is the fundamentals and making sure that the cloud native principles are understood and everyone will be able to use them to build further.
That is a very good way of putting it, because you're right. Some people, or including myself, I think wow, there's so much choice. This is so confusing, but I'm spoiled. I'm spoiled for choice, right? There's so many approaches. Exactly. And there's no one better than the other. It's all contextual. So I'm complaining about the choice, but really a lot of hard work went into creating those choices to begin with. And the reason why there is so much diversity in choosing, not only the diversity of choice, but also diversity of the community is very diverse, is because there's so many approaches. So how do you surface all those approaches? And if anything, the cloud native landscape does a really good job of highlighting and showing all these options, which I think is a great thing to have. Mm-hmm. So picking and mixing things, it's very interesting. And that in itself can be a job, right? Curating these approaches. So in the cloud native fundamentals in the course, did you do any of this curation, or how did you pick basically the approach that you follow or that you recommend?
So when I was actually building the course, I really had the audience in mind who is actually going to take this course. So I was trying to make it easier for them to navigate the ecosystem, because there, as I mentioned, there is a canvas full of different tooling and you can pick and choose, can make a great platform. But is it actually something that someone who wants to start with cloud native needs to know? So I was trying to break it down to the bare fundamentals and again, explain the principles. What cloud native is. It is about being declarative. It is about these self-healing capabilities, containerization. You have interoperability that you've mentioned. You have multiple solutions for the same problem. That's why we have such a diverse landscape. So when I was trying to choose the tooling, I was trying to make it easier for the students. Mm-hmm. So at the beginning, I was trying to explain that you have an application. The only requirement a student will need is to have some programming experience, because based on an application, we're going to move it forward to different phases to the point it's going to be within a production cluster. So having this application, what do we do with it? We start thinking about its architecture. Is it a good application to be containerized? So we're starting kind of with those kind of mindset and perspectives around the service. Then we're thinking about how can we containerize it. So usually we're going to look at Docker. So Docker has been there for a very long time. It has been given the standards of how we package an application as well. So it's a very good kind of knowledge to have. And once you understand it, even if you use other tools, which does this packaging of your application by default in a package, for example, we have tools such as Buildah or Podman. They package it for you quite nicely without you even having to run one line of Docker file. But for them to understand how to package it is quite important. That's why I want a bit more declarative when it comes to packaging an application, creating that artifact, a Docker image. Kubernetes by itself, it was one of the focus as well. Like when you're talking cloud native, there is going to be an element of container orchestration. Hence, we kind of talked about Kubernetes resources and how it actually schedules different resources and applications, how you can expose your application to the wide world using ingress and services. So pretty much still trying to explain the basics, but not go too further up. So the bare minimum that they will need to deploy an application. The interesting things is, however, when you choose a CI/CD pipeline, because there you have so much choice around the tooling. One thing that I've purposely done, I've split the CI and the CD into two different lessons, because most of the people, like they cannot really differentiate the stages within a pipeline. So I was trying to choose the tools. I was trying to, again, one of the things was it has to be open source. So when I was choosing GitHub Actions, again, it's something which it's quite well maintained by the community, have a lot of pre-built, a lot of kind of actions that you can use straight away. And with Argo CD, again, I wanted to make it easier for students instead of all the time being in the terminal. I wanted that UI element of deploying and maybe visualizing your resources. So that's why I went with that approach. So I think, again, I was trying to put the bare minimum of how can you have an application, package it, deploy it, have it like automate the deployment process and have it running within a cluster. And I was trying to choose the tools purposely to kind of fit these fundamentals and make it very easy for them to move forward.
Okay, so you mentioned that you split CI and CD. And based on the tooling that you mentioned, the way I understand it is that you use GitHub Actions as the CI.
Yes.
And Argo as the CD.
Precisely.
Okay. And why is that? Why did you split CI and CD? That is interesting.
So I wanted to make it very clear what is continuous integration by itself and what is continuous delivery by itself. Because continuous integration usually focuses on the code. Yes. How can you actually integrate the latest features from your application within an artifact? So the end of the CI should be an artifact. So I wanted to make that very clear. So with the CI, you can have, for example, testing in different environments. You can build artifacts for different platforms. However, at the end of it, the result should be an artifact. So I want to kind of to make that very, very clear. With the cloud native space, that you're just going to be represented by a Docker file, which will be able to run on any platform that run containers. So I've kind of separated that. And when it comes to the continuous delivery, it's how you actually ship that artifact to different environments. So I want to kind of to make it clear that a pipeline, in a way, should do continuous integration and continuous delivery, should contain all of these stages. But I don't think there is a very good understanding of where exactly continuous integration finishes and where the continuous delivery starts. I want to kind of break it down to, again, bare fundamentals. Like you can still have two different tools, but you can still achieve a very functional CI/CD pipeline. You don't necessarily need to use one tool to achieve the end result. You can actually kind of have this puzzle, put two pieces together. And this is something, again, I wanted to maybe accentuate the nature of cloud native. You have different tools, you put them together, it works. So that's another thing I wanted to highlight. Again, which was not the main focus. I wanted, again, to make it clear, to differentiate it. But if you're looking from a different perspective, we can see this interoperability. We can see this diversity of the tooling. We can easily switch the Argo CD, for example, with Flux. We can use Spinnaker instead. We can use any other third-party provider. Like you can actually change that with GitHub Actions. You can completely use maybe Circle CI if you have that within a house. Like you can really choose different tooling here. But I wanted to maybe emphasize what are the stages and what is the result of all of the stages. Make it simple.
That is really interesting because even though we don't call it out like that, to basically build and deploy changelog.com, the app itself, we do something very similar. We use Circle CI as the CI, where the end result of the pipeline is a container image. So if tests pass, if dependencies get built, we compile static assets, JavaScript, CSS, and the end result is just a container image. And for the CD part, it used to be 5 lines of bash, which would be like while true, update service that was Docker Compose days. That's all it took, literally Docker update service with like the latest image. And we replaced that with something called keel.sh. I'm not sure whether it's part of the CNCF, but it runs in the context of the Kubernetes, so you deploy it. And it's, well, first of all, it receives webhooks from Docker Hub. You can configure it like that when there's like an update to the image, and then it will update the deployment with the latest version. I know that this goes against the GitOps mindset and the GitOps philosophy. I think that's a very interesting topic, which I would like us to dig into. But that's all it takes. And this separation, just like to highlight what you've been mentioning, this separation works really well in that you don't have to change your CI to change your CD as well. They're like two separate things. And whether it's 5 lines of code or whether it's GitOps, whether it's something else, doesn't really matter. The point is you have this choice to maybe change them independently and not have them coupled together. So migrating in our case from Circle CI to GitHub Actions is easier than if we had like this really huge pipeline that had all sorts of secrets and it knew where the Kubernetes clusters was running and it needed access to those. So definitely works. I can definitely say that it works. And that's why I was trying to understand a bit more why I do that, because it's a very good approach. It's a really good approach to separate the two.
Absolutely. So again, here is just preparing the mindset for you actually build your own pipeline. And it's more about the internal requirements you have within an organization. If you cannot use open source tools, then probably you'll need to run your own Jenkins servers and run your CI/CD pipelines there. And that's absolutely fine, because even if you use Jenkins, you still need an artifact. You still need to deploy it within an environment, be it in a data center. It doesn't necessarily need to be a Kubernetes cluster, but the fundamentals are there. So I'm trying to provide this information that they can reuse in different environments.
So I can see this philosophy. I call it the Unix philosophy, the small utilities, then combine and compose in infinite ways. Is that what cloud native is to you, or is it something else?
I think it becomes that. I think what actually draws me to cloud native is the diversity of tooling. Not necessarily the tooling, the strategies, because I've been interacting with many organizations. I've been talking with many engineers, and when you're talking about infrastructure and their platform setup, not one platform is going to be the same. Even if they use Kubernetes as the core, the way they use Kubernetes, the way they deploy to Kubernetes, the way they bootstrap the cluster, maintain it, all of these answers are going to be different for every single organization, pretty much. Like, I haven't seen too much overlap between from one setup to the other. And I think this is the beauty of this environment of cloud native, the diversity, this inclusivity of multiple solutions. You can actually leverage your product further. You can use very good fundamentals. You have a platform that pretty much can schedule your application, can take care of it, can restart it. You have higher abstraction layers to maybe scale your application and so forth. You have the fundamentals. What you need to think about is how can you further leverage your product and maybe use the tooling that are right for your organization in terms of the budget, in terms of the resources you have. Sometimes outsourcing is going to be the answer. Sometimes building everything in-house is going to be the answer. So it really varies. But the interesting part about all of these platforms, they're different, but they leverage open source at the same time. And they try to contribute. And this is, I'm kind of amazed, because these small adoptions, this small integration builds up to this organic growth of the entire cloud native ecosystem and open source tooling at the same time. And this is maybe something very, very miraculous to observe and actually see how it grows. Like, thinking about Kubernetes, it's been around for 7 years. It's actually marking 7 years now, but it completely changed the way we have these application deployment strategies. It's like we had the VMs, and this was the buzz thing maybe 10 years ago, but within 7 years, everything just changed completely. And we have a lot of data, a lot of surveys and reports showcasing this. We see enterprises actually thinking about Kubernetes. They're thinking about multi-cloud strategies. And because Kubernetes is agnostic, you can run it on any compute. It can be any cloud provider. As you have some compute, you have some networking components and storage, of course, you'll be able to build a cluster anywhere. And this is the beauty of it, because you can leverage this and build it multiple clouds, and you can migrate your applications quite easily using the same abstraction layer. So the beauty of it is it's a pluggable system. It's interoperable. It's diverse and organically growing. And I think this is something which is quite important and maybe something which is not easy to replicate. Like, I don't think any organization will be able to maybe have the same success with an internal tool of kind of growing and gathering ideas from different communities and building it up. So this is kind of, again, the beauty of the cloud native, and maybe that's why I'm within this space still.
Yeah, that is a very good answer. And I think if you take away Kubernetes, what are you left with? So Kubernetes definitely always like the center of it all, and many things are built and are being built on top of it and around it. But if you remove it, I think we're starting to see other scheduling platforms. I don't know whether they slowly emerge, but there are other options. And I think people sometimes say, you know what, Kubernetes is too complicated. Say, okay, well, we can use something else, but the problems that you have to solve will still be more or less the same. So sure, you can use something else. I don't know. If I'm trying to think, if I wouldn't use Kubernetes, I think I would try maybe Nomad out. I don't know. What would your choice be, Katie, if you maybe, let's say you couldn't use Kubernetes, what would you use?
If I couldn't use Kubernetes, that's an interesting one. What is life without Kubernetes? I've been working with it for so long. I'm quite biased here. But I think it really depends on what kind of applications I have here. I'm actually again, biased from something that I would like to maybe deep dive more. Serverless is something which has been extremely beneficial for many organizations. So if I have an application that has to be there for a certain amount of time, it's something which is time framed, let's put it this way, then I think serverless is definitely something to have out there. Again, depends on the organization, but something in me would be like, I don't want to go the data center way again, because I think, actually, I don't mind this, but I think this is a space which requires a bit of modernization as well in terms of how we set it up. If the tooling is right, if the mindset is right, I think it can be a very good setup there as well. If you have an organization that is very restricted and has to deal with a lot of compliance, then definitely data center is going to be the way. But yeah, I think, and my answer here is I don't have one specific platform. It really depends on like what I would like to deploy. I think the cloud providers have very good offerings around anything that you'd like to deploy. They have stacks built for you straight away. So sometimes you just need to put your application in and then you're going to have it running somewhere. As long as, like, for example, if you don't care where it runs, you don't care about managing your infrastructure, they'll be able to run it for you somewhere and it's going to be available to the customers. So my answer here is, as you mentioned, there's a very good diversity to containers as well, to maybe Kubernetes as a thing. But it really depends on what you would like to deploy. Based on that, you'll be able to choose maybe some more specific tooling, something which is right.
Yeah. A PaaS, now that you mention a PaaS, may work for sure, because you're right. I know there are many efforts to abstract Kubernetes away. It's an implementation detail, as the load balancers used to configure them, and now there's just like an implementation detail. It's just an ingress. Same way, maybe you don't need Kubernetes. Maybe what you actually want is just a PaaS. And in some cases, maybe not even that. Maybe you want a serverless platform that you just, push your functions and you define your integrations and inputs and outputs and all that stuff. And that's it. That's all you need. So that is really interesting, because I think, again, going back to the choice comment, I think we're really spoiled for choice these days. And then if you're trying to like cling on to your bare metal machines, that's okay. There's nothing wrong with that. But I don't think people can be as exclusivist anymore. It's not like this is the only way and that's it. I mean, you have to be blind to not see all the other ways, which, by the way, in some case may work better. You may be spending less time toiling away at your infrastructure and maybe focusing more on the business. I don't know. That's just a thought. I know it works well for some.
This episode is brought to you by our friends at LaunchDarkly. Feature management for the modern enterprise. Power testing in production at any scale. Here's how it works. Launch Darkly enables development teams and operation teams to deploy code at any time, even if a feature isn't ready to release to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release more widely, update the flag status, and the changes are made instantaneously by their real-time streaming architecture. Eliminate risk, deliver value, get started for free today at launchdarkly.com. Again, launchdarkly.com.
Imagine, Katie, that this is your first day in a new job. You're leading a team of 5 or 7 developers. You're the lead developer here and also have a bit of an architect role. And the brief is to design an online presence, an online store for a supermarket that needs to service mobile applications, web browser, web applications as well. So mobile and web applications, but you're in charge of building the API, handling the data part as well. And then there's some other front-end teams which maybe build on top of it. And by the way, that may not be a good division. And you would point it out if it's not, right? Whether the front-end team should be separate from the back-end team. I don't know. But how do we build an online store, Katie?
Well, it depends on which stage we are of building that store, because having a first MVP, I think it's more important than having the full architecture, like grounded down to every single service that is going to be covered within this store. So at the beginning, the first MVP, what is actually a store? So of course, we're going to have a web interface. So this is what the customers will interact with. We're going to have a database, which is going to be pretty much storing all of our items that we'd like to sell. We're going to have a backend, which pretty much will connect the two things together. So pretty much we'll take any request coming from the front end, make sure that it has all of the information from the database and kind of provide back the response. So these are kind of let's put it, the three major things, usually like the front end and the back end. And then you have a database there, database component as well. This is going to be the bare minimum. But the fun part starts when the backend actually is not just about kind of getting requests and providing a response back. It's about maybe expanding to different functionalities as well. So when talking about a store, we have a shopping cart. We can have, for example, different currencies with like our price to be displayed. You might have, different languages. We have different categories. Maybe we have even different portals for different stores, which are managed by the same company. So one is going to be the groceries, that one is going to be the clothing. There are so many varied things. Maybe the interface is going to be the same, but some of the functionalities can change, for example. So you can really go the extra mile and personalize the entire experience for a user. But starting with, I think it's have the first MVP. You don't need to segregate everything across 3 repositories and have everything, again, nailed down on an architectural level. Have it working. So a front end, a basic front end, a basic back end, and a database running, maybe even locally, and then that's it. This is going to be the monolithic approach. So if this is just for testing maybe, or this is just at the level of the MVP, I think having a monolith, it's fine at this stage. However, as you've mentioned, if I'm in a team with a couple of engineers, 5 or 7 engineers, I might have a front-end team, or I might have even the ability to employ new people and create different teams across the organization. In that case, that's when we start to think about, do we need to split up this application into different components? And most of the time, the answer is going to be yes, because you want your application to be resilient. If one component goes down, you don't want the entire application to be down. So for example, if the shopping cart is not working, that functionality specifically is not working, everything else on the store is still working, but people will be able to still visualize, maybe they will still be able to get their order confirmation or do the payment and so forth. So you really want to segregate things. You really want to reduce the blast area if something goes wrong. And this is where usually the answer, are microservices good for me at this stage? The answer is going to be yes. But again, you have to think, how do you would like to split those services? We've been talking about the front end, the back end, the databases, but then we can talk about the payment systems. You can go the extra mile there because you have different payment methods nowadays. You can go with the shopping cart, the currencies. Again, you can have different teams, different services for all of these applications. The other thing that I want to mention here is that once you have kind of a set of microservices, that is not the end. Always should consider and kind of make sure that you reiterate on your application, on your code bases. Because if, for example, you've written one microservice using Java, because that was the main resource knowledge that you had within the organization at that time, it was working, it was perfectly fine. However, you would like to optimize. So for example, Java is going to be very heavy on the CPU consumption. And then you realize you look into like your machines and you would like to save some of that compute. And you're thinking, is it the right time to rewrite this microservice using a different language? Actually, there is a capstone project. The students will have to rewrite something from Java to Python, and they will observe this differentiation of CPU consumption. So having these maybe different languages and segregation of services allows you to have kind of independent management of these applications. Mm-hmm. As long as you have a very well-documented API and you know how different products should call each other, you have a standard, you will be able to pretty much have this independent development on the services. And one thing that I wanted to mention as well is, I've started to talk about this, you have to reiterate. Something you've been segregating in different microservices can be too granular. So you might thinking maybe putting some of the currency and payment microservices. You find this too granular, there's too much management, which is because once you split them, these services, you have usually a different code base, you have maybe a different language, you might have some other teams managing independently. Sometimes having them together is the answer as well. So merging two microservices, that's an operation, or you can further split an application or a service to make sure that you have a better management of those services. Some of the services are completely stale. So for example, you've developed a very, maybe a very kind of personalized shopping cart experience that no one is using. That's one of the microservices that it's not used. You might be marking it as stale and completely retire it from your cluster and from your application. So what I'm trying to say for all of these operations on microservices is dynamic. It's not set in stone. So you have an application, you might split it in microservices, but that's not the end. You always have to reiterate and consider what is the best for your application team, for your business, and for your organization at the time. And always kind of try to optimize and improve. This is kind of the answer to kind of many of the technology advances that we have nowadays. How can we further optimize it? So it's a journey. But again, one thing that I want to mention here, do try to understand the requirements of your organization. Everything is going to be driven by those. So if you're an organization that really wants to scale up and they have all of the resources in the world, maybe that's when you're not going to think about optimizing your application. For you, the primary thing is going to be available out there. You have enough scale, you have enough resources. So cost optimization is not going to be something you're going to look at very frequently. However, for an organization which is in a startup, they will be trying to use all of the free level tiers resources that a cloud provides, for example. So you'll have to be very thoughtful about the resources you use. You might choose some of the tooling that are free tier just because it will get you in a position where you can still run, but be very efficient with the money you have. So really try to understand what you have at the moment and try to build with the resources that you have.
So what I'm hearing is it depends.
Yes.
It depends on your context always.
Short answer, yeah.
So that's the first thing. But starting with a monolith as an MVP does sound like a sensible approach, especially if you're trying to prove a concept. And then, based on that, it depends on how things go. You may decide to break it down into microservices. Where would you run this application or sets of microservices? Do you have a specific preference? I mean, we keep mentioning Kubernetes. Would you run it on Kubernetes or would you use something else?
So I actually have many people asking me that. So some of my friends, they're actually developing products, startups, very small startup companies, and they're asking, is Kubernetes the right thing for me at the moment? And usually my answer in that circumstance is going to be probably no, because it's just only two people, both of them developers. They don't have any infrastructure developer or like cloud platform engineer within their team. So for them, managing and completely kind of deep diving into Kubernetes architecture and management, maybe it's not the answer for them. So in that circumstance, I would usually maybe suggest a cloud provider. Again, you have free tiers you can use from different cloud providers. So I would usually recommend that. However, if you are in a circumstance where you have enough engineering resources and you have enough expertise of maybe understanding how to run an infrastructure, not necessarily Kubernetes, but the basics of what is actually an infrastructure is composed of, then probably Kubernetes is going to be the answer moving forward. Because when you're talking about Kubernetes, it's not just about containers, it's about how these containers are managed and what kind of leverage you get in a production environment by using Kubernetes. So I've been mentioning the scheduling capabilities. So for example, you have, maybe I should introduce Kubernetes very, very briefly. So Kubernetes is pretty much an orchestrated platform for containers that is run across a distributed amount of machines. So you can have different instances, and all of them are going to be kind of put together to run your applications. Now, on which node, on which instance, that doesn't really matter. That's always going to be abstracted by Kubernetes. So one of the capabilities is going to be the scheduling. So based on the requirements you have for application, for example, you can choose this application should have this amount of memory and CPU at all time. This is the very minimum of the resources I need for it to be up and running. The scheduler would take these requirements into account and place it on a specific node that will have all of these available resources. Now, the thing is, if that particular instance goes down, usually, if you'd be working in a data center, you'll need to migrate your application, or you'll pretty much need to trigger your load balancer to point to a different data center. Now, with Kubernetes, all of this is automated. So Kubernetes will be managing or monitoring the state of your application all the time. It will see that it's no longer up and running, and it will go back to the scheduler, and this will put it on a different instance, again, with enough resources and capacity to run your application. So all of these operations are automated. And this is just one of the functionality it provides. We have scalability. We have resources which will allow you to scale an application based on different events. So for example, if you reach the amount of maybe the maximum of the CPU or memory your application can consume, you'll be able to scale further. But now you can actually scale on external events as well. So for example, maybe there is a queue you have in SQS messaging queue in AWS, so you'll be able to take those metrics and based on that maybe scale further. You can really go the extra mile nowadays, so you have a personalized scale mechanism. And all of this, again, is automated. You have declarative representation of your application. So your application is represented as code. It's in YAML. It's not necessarily the most readable thing out there, but it's out there, and that's going to be representing the desired state you want to have within the cluster. And that desired state is always going to be fulfilled. So you have control managers, which will always make sure that what you want is actually going to be in the cluster. And it's in a loop to reach that perfect, ideal condition that you define within the manifest. So these are just some of the functionalities. I didn't even talk about the ingress and how you actually manage the reachability to your application, how you have this abstraction across a collection of pods with services, and how can you have granular control of how your application serves different HTTP endpoints with ingress, or how your ingress can actually point traffic to different services and different applications. So you have a lot of availability out there, and you have custom resource definitions, and you really can go the extra mile. It's a tool that is very customizable, but more importantly, again, it has some of the basics very well set, so you don't have to think about them anymore. You just take advantage of them straight away. So in that case, if you have a team that would like to run an application within a production environment, would like to kind of take advantage of all of these capabilities that Kubernetes provides, and they have enough resources within an organization to run it, then probably the answer is yes, do look into Kubernetes and start rolling it out.
I would definitely agree with everything you said from practical perspective, because even though changelog is a monolith, the reason why we chose Kubernetes is that it takes care of certain details in a very elegant way. We can declare everything from certificates to DNS to load balancers to even cron jobs. It has even the concept of cron jobs. So, and these are just like the built-ins, never mind the specific CRDs, the custom resource definitions. So you can enrich it in so many ways. And it's a really nice tool to work with, which seems to do very many things really well out of the box. Maybe some of them you won't even need. You have policies, you have like the whole the network policies, the built-in security model. I forget what it's called. I think OPA is one of them, the open policy agent. So you can define certain constraints, certain requirements that need to be present. So what I'm saying is it scales really well. So you can do so many things that would be very difficult to do in a different platform. And it just takes a lot of resource and a lot of knowledge and a lot of just time. Now, the good thing is once you learn it, it applies to anywhere Kubernetes runs because it's literally the same API. A few differences, but the same API. Maybe the persistent volume that you get is slightly different, and the load balancer has like some extra things based on the platform that you choose. But the language is the same. So you have this unified API, and it just makes things happen, which is amazing. Not just once, continuously. So that's great. So you're right. You can have a single app and still get a lot of mileage out of it if you want to or can afford to invest that time. Otherwise, maybe a platform as a service. Maybe that's going to be all you need. Maybe something like Heroku or Cloud Foundry, or I think Render. That's like the new version of Heroku. Different options like that. So there are options. Now, you wouldn't choose or you wouldn't start with microservices to begin with, would you?
Probably depends on the scale. But like if I have a running MVP, it's a monolith, I'm happy to kind of move it forward and create this automated pipeline for it if needed.
How do you get updates out into production? What would you use for that? Let's say that you have a monolith. What would you choose to get updates out into production?
So here's where we would actually have this pipeline. So I was actually wondering what a pipeline is, because when I first heard about it, I was an intern at the time, and there was this magical pipeline that can push changes to the production. And sometimes it can take days because you have freeze changes and so forth. But a pipeline pretty much is a mechanism that will be able to roll out changes that you have within an application to the production environment. Ideally, that's going to be automated. And this is what is nowadays known as the continuous integration or continuous delivery. So CI and CD. And with the CI and CD, you usually have different stages that you'd like to go through. So once you have your application, you developed a new functionality. The next thing is actually to have some tests. I think this is quite a natural thing to do if you want to have something secure in production. It's very often overlooked, but definitely do write your test and actually do think what are those gaps that you might want to catch before pushing to production. And some of them are quite easy. Maybe some linting is going to be the answer, maybe syntax checking and so forth. So there are tools that does that for you. So do look into kind of integrating those tests. So you have your application, you test it, it kind of passes everything you've been writing out there. The next stage is the packaging, building that artifact. So when we're talking about an environment where we had data centers, usually the artifact is going to be a binary. And you can have different formats as well, depending on where we run it, on which operating system and so forth. When you're talking about cloud native, there's going to be a container image. So usually a Docker image. And what's very good about the Docker image is that you can have a set of instructions building your binary or your artifact. So, and that's something, again, declarative. You can reuse that. You can change it accordingly. Or if you don't want to use Docker, for example, you can, as mentioned before, you can use a tool such as Podman or Buildah, which will build all of these kind of the container image straight away for you. And once you have this image, usually you'll need to store it somewhere. So that's going to be, again, in different environments, it's going to be Artifactory. With Cloud Native, you'll be able to use something like Docker Hub. You can use Harbor. You can use Artifact Hub currently available. So there are options to store your image out there. So this is going to be all of these stages. So building a functionality, testing it, packaging it, and distributing it. This is going to be the continuous integration. So you've integrated a new functionality, and your end result is going to be a binary. Now, the next stage of it is, how do I push this binary? How do I push all of these changes to the production environment? And this is where we have the continuous delivery. With the continuous delivery, usually we have to pretty much propagate the application for different stages. When you're talking about an organization that, again, has resources, usually there are 3 to 4 environments that you will need to pass it through. The first one is going to be the dev environment. You might have a QA as well. Debatable. Some companies do, some companies don't. Definitely have a staging, and then the final one is going to be the production. So the reason you actually have all of these environments, and more importantly, they should be set up similarly. So the difference between them is just maybe the endpoint you reach to that cluster, so the API endpoint. But everything else in terms of the setup internally is going to be the same. So what you actually do within the continuous delivery process is propagating it from one environment to the other. So QA, staging, and production. And the passing through all of these stages, the result should be the same. The application should be up and running. So you have at least two possibilities to verify your application and how it responds to the other components within the cluster. It's not just the application running, it's about how it affects other components within the cluster. And if it doesn't and everything is fine, even greater. So once you reach the production stage, this is pretty much the continuous delivery process. And hopefully it's going to be up and running all the way through. So these are pretty much all of the stages that we have.
Yeah, that's a good one. Argo CD is what you're thinking for CD?
Yes. So I've actually had to battle a bit with the instructor project manager because they wanted to use a more traditional tool here, but I was very, very set up to maybe promote or maybe not necessarily promote, but advocate for the GitHub strategy. It's something which is there, and it's been a buzzword for the last year for the practitioners and the experts within the industry. I think they are completely tired of kind of hearing this term. However, for students that kind of are on the journey to start the cloud native journey, I think it's important to kind of maybe set up the fundamentals of what GitOps is. And now within the cloud native space, we have Argo CD and Flag CD provisioning these capabilities. And both of them currently are incubating CNCF project. And Argo CD is currently undergoing a graduate vote, which means it's stable, it's been used by hundreds of customers. It has a very healthy community, it has a very healthy development velocity and so forth. So it's a healthy project, it's out there. So Argo CD, actually, the reason I picked it up, it's mainly because it has these web UI. So it'll be easier for students to visualize their resources, because once you have a cluster, the only chance for you to interact with it is going to be through the CLI, the command line, which is still something not very comfortable for someone who starts to understand Kubernetes. So I wanted maybe to provide an extra support, a visual support for them to visualize those resources. So that was the main reason, because I think it's going to be easier for the intended audience here. But that doesn't mean that one is better than the other. It's pretty much, in the context, I think it's the best tool at the moment.
This episode is brought to you by our friends at Cockroach Labs, the makers of CockroachDB, the most highly evolved database on the planet. With CockroachDB, you can scale fast, survive anything, and thrive everywhere. It's open source, Postgres wire compatible, and Kubernetes friendly, which means you can launch and run it anywhere. For those who need more, you can build and scale fast with Cockroach Cloud, which is CockroachDB hosted as a service. It's the simplest way to deploy CockroachDB and is available instantly on AWS and Google Cloud. With Cockroach Cloud, a team of world-class SREs maintains and manages your database infrastructure so you can focus less on ops and more on code. Get started for free with a 30-day free trial or try their new forever free tier that's super generous. Head to cockroachlabs.com/changelog to learn more. Again, cockroachlabs.com/changelog.
That's really interesting, because you're right. The reason why between the two, between Flux CD and Argo CD, I also prefer Argo CD because of that visual element. I think the UI is really nice. Not only that, but I'm seeing that other projects, like for example, Kubeflow Pipelines, which is about machine learning, they also use the concept of Argo CD workflows behind the scenes. So now we start seeing that other projects are building on top of projects which were not meant to be used like that, but they're really flexible and they work really well. And they have like nice UI elements. You just get the UI for free. So it makes sense for example, for machine learning to use something where you can see a UI. I think that that's really powerful. So it just goes to show that a tool, sometimes people use it in unexpected ways, which are good and many people like. So, and this is like where something new and unexpected just happens. You know, nobody planned for this to happen, but it's a good thing. So I think, another vote.
Yeah, be responsive to customer feedback here. Definitely agree on this one.
Yeah. Another vote for Argo CD from here. And for CI, I think that's maybe less important. And the reason why it's less important is because, first of all, people have been doing this for such a long time. So you may already have a preference. So whatever you're using is fine. GitHub Actions is there. I think that's what you're recommending in the course for the CI part,
Yes.
because you're so simple. I mean, you have to store the code somewhere, and then wherever you're storing the code, having the CI part as close as possible to that, I think makes a lot of sense. So that's like fairly easy. And for those that use GitLab, well, you already know, but you're taken care of. So that, again, doesn't really matter. You know what to do. So that's really interesting. Okay. What about monitoring, telemetry, logs, traces, events, any such things? Would you introduce that at these early stages, or would you just maybe mention a couple? How would you approach this?
So this is a very good question, because one of the things that I'm trying to, again, advocate for is, as an application developer, you don't necessarily need to understand your infrastructure, but you need to know where it's going to be pushed or where it's actually going to be running and executed. And this is actually quite important, because when I was talking about, like, I'm talking within the Kubernetes context here. When you have an application, it's quite important to have this readiness and liveness probes, which automatically can restart your application if something goes wrong. So instead of someone waking up in the middle of the night and doing that, the cluster will be able to do that for you, as long as you have a health check-in point out there. So what I'm doing at the beginning of the course, and kind of making sure that everyone understands, is be aware of your application is going to be executed. So there I'm talking about the health check-in points. I'm talking about the metrics endpoints if you want to export any application-specific metrics. I'm talking about logs. Be sure that you're actually logging on different stages within your application, different functions when they are called, and so forth. I'm even talking about traces as well, because some of the traces out there, or some of the APMs at the moment, they require for the libraries to be used within the application to have this super fine granular representation of how a request is actually solved and how a request is actually getting the response from all of the functions that are called and so forth. So you can actually build all of these components together and have the full journey. So I'm talking about all of these components and kind of making sure that the students understand them. However, these are going to be covered even further in the next course. I think it's going to be course 3, which is going to be solely focused on observability. They will talk about Grafana and Prometheus for metrics collection and visualization. They will talk about Jaeger for tracing. They will even touch upon how can you actually build these dashboards and panels, and making sure that you have a very good representation of what's going on inside your application. And this, again, I'm just like covering them kind of as a beginning fundamentals. It's just kind of making sure that you understand what it is about. But they're going to be used throughout the course. And the capstone project, which is at the end, and this is something that I've developed as well, the students will really need to kind of be very, very thorough in building their dashboards, because these are going to be quite crucial for them to get these results of CPU consumptions between a microservice that has been rewritten in a different language. So they'll have plenty of chances to practice their observability skills as well.
That's a very good one, because people don't think about that. And I think based on the platform that you choose, it can be either very easy or very hard. Once you're really well into your journey and you think you have it and everything is looking good, then you discover, oh, hang on. So now I need to understand how my application behaves. Yes, you do. That's something that you should keep in mind from the beginning. And based on what you choose, based on the platform that you choose, it can be either very easy or very hard. So sometimes it can be, straightforward. And even then, the straightforwardness is like in the approach, because there's this complexity associated to what you care about, what your application does, how it's structured, or your microservices, how they're structured. And it's all very contextual. So it's very difficult to maybe build something that is generic. I mean, you could have an APM and that may be good enough and you would have some traces, but is that sufficient? Maybe it is, maybe it isn't. I don't know. That's where it depends. It basically starts to depend more on the context and less because it's less generic. So that's the first thing. Instrumenting your code, that started becoming more important, right? And only you know where to put those instrumentation calls. Nobody can tell you because it's your code. So there's that.
I completely agree on this one. Yeah, and one thing that I want to mention here is that this need of understanding where your application runs is kind of bringing this need for the DevOps practice. I know it's been completely consumed as a topic. But for students that, again, are on the journey of understanding cloud native, maybe they have been a programmer, they have been training to be a software developer, but they looked into cloud native and they wanted to transition. I think it's important for them to understand that DevOps, it's not a tool, it's not something physical, it's a culture. It's pretty much, as you've mentioned, like as an application developer and as an infrastructure engineer, how do we leverage the product further? So this collaboration, for example, you're using a particular tracing application, or you need to kind of run or integrate some libraries to collect those logs. So you actually can visualize them in, I don't know, it can be, for example, in Splunk or Datadog, depends on the tool of choice that you have within the house. So this collaboration is all about making sure that you have this full transparency of what's happening at the application layer, and the infrastructure team will be able to leverage that with the tooling that they provide. Okay, so as you're approaching the end, I hope that you really enjoyed what Katie's been saying, because I have. And the course is currently free, or will be free. There's something like free in the tweets. I think it's not very clear. Some people are getting confused about that part. So can you help us, Katie, understanding it? Absolutely. This is something that I'm clearing out myself as well. So the course, the way I build the course, it's supposed to be free. However, because it's part of a wider nano degree, so I'm just kind of having a fourth of the entire nano degree. So there are 4 courses. The first one is going to be Cloud Native Fundamentals. The second one is going to be Message Passing. So we're going to talk about gRPC and Kafka. The third one is going to be Observability. And the fourth one is going to be Security. So I am teaching the first one. So this is kind of a wider nano degree put together. So my course is free, but at the moment is not yet available as a standalone free material. It is going to be available later on this summer. Unfortunately, it's taking longer than needed. But this is because currently we are having 15,000 students that are doing the first course that haven't been built. And once they finish this course, they'll be able to pretty much open it to the wider community as well. So it is going to be free. It is intended to be free. I am not charging for it at all. So I've built it purposely to kind of part of my motivation to make Cloud Native ubiquitous, making it accessible and available to everyone. Even if someone who doesn't do any technology at all, I hope they'll be able to have some programming experience before, and they will be able to roll out for the entire course as well. So currently, it's not yet available, but once I have the links, I'm going to share it and make sure that everyone will have it, and everyone is actually looking for the feedback from everyone as well. Yeah. Thank you. So that's great, right? Like maybe by the time you're listening this, the course will be free, or just like a week or 2 weeks away from becoming available, so you can take it. And that is the free part. I'm sure that there will be a course that people will be able to pay you for it if they want to, right? Hopefully. No? There should be a paid version as well, right? Yeah, the entire nano degree is paid. That's why people are currently asking, where is the free material? So the entire nano degree, that it's actually having a price. So if you want to take it as part of the nano degree, maybe your organization already has affiliations with Udacity, which means you don't have to pay for it, which is great because many organizations have these training programs internally. They have a lot of contracts with these vendors as well. So maybe you'll be able to take it completely free because it's already paid for. However, if someone would like to do it, you'll have to take the entire nano degree and pay for it. That's the only option. Once it's available as a standalone material, I'm going to be able to share it further, because the feedback so far I've been receiving, it's actually great, because I've been developing this course in starting November 2020, and I finished it in January 2021. So it's been quite intense. I would say it's been 4 months from the beginning to actual end for me working on it. And now it's been half a year since, and actually I can see that the students do find it useful. It's been difficult for me to realize the impact. One of the motivations again for me is to grow the next generation of cloud native practitioners, to make it easier for them to transition within a role that has cloud native elements. And I've been developing this, but I haven't seen any results. So now I'm actually starting to see those, and it's really delightful to see students from across the entire world sending me messages on LinkedIn and requests, and they're like, the material is great. I really understand everything you're saying. I would like to learn further from you. That's how I would like to connect. So it really inspires me to, again, it's been a great work that I've been doing, and I really hope it actually reaches as many students as possible.
Thank you, Katie. That sounds wonderful. Thank you for putting in the time, for caring enough about this, because it is important, but maybe many people don't realize just how important it is. As time goes by, I'm sure this will become even more and more relative and relevant and relevant. That's the right word. And people will enjoy that such great materials exist. So thank you, Katie, for taking the time. If you have not heard of this course, go and check it out. It will be in the show notes. Give Katie feedback, what you liked, what you didn't like, how she can improve it, because there's always scope for that, right? To improve, to make it better. But I think you will really enjoy what's already out there. If you just look at the blurb and like the description, there's a lot of very valuable content. Katie, it's been a pleasure. Thank you for sharing this with us. And I look forward to speaking with you sometime soon.
Thank you for having me. And there's one last thing I would like to mention is taking the course is just the first step. One thing that I'm actually calling out at the end of the course is do reach out to the community. And I'm expecting everyone in the cloud native community. And I think this is an action that I would like every student to take if possible. Being part of the community does not necessarily writing 1,000 lines of code and be out there. It's being present, is sharing your experience of using cloud native, is reaching out to the community. So the community is out there and we are expecting you as well. So please do reach out and let's grow the next generation of cloud native practitioners. That's the high purpose.
Thank you, Katie. That's it for this episode of Ship It. Thank you for tuning in. We have a bunch of podcasts for developers at Changelog that you should check out. Subscribe to the master feed at changelog.com/master to get everything we ship. I want to personally invite you to join your fellow changeloggers at changelog.com/community. It's free to join and stay. Leaving, on the other hand, will cost you some happiness credits. Come hang with us in Slack. There are no imposters. Everyone is welcome. Huge thanks again to our partners, Fastly, LaunchDarkly, and Linode. Also, thanks to Breakmaster Cylinder for making all our awesome beats. That's it for this week. See you next week.